All right, so we're back to evaluating function notations. When you evaluate a function notation, it depends on what is given. In this problem, we're given a graph. Sometimes you're given an equation, right? So the important thing is that we understand what is the general format of a function notation. It normally looks something like this: f of x equals y. Okay, so that's really what it is. So meaning whatever is inside these parentheses, that's your x value, and whatever is after the equal sign, that's your y value. Okay, so for instance, if I have f of 2 equals 3, in other words, this can be written as a 2 comma 3, meaning this is your x, that's your y. That's really as simple as that. Okay, all right, so now let's consider a graph, the graph below, which looks like a W, right? So this is a quartic function, meaning and the highest exponent is 4, and you would know it because it crosses the x-axis 4 times. So that means there are 4 solutions to this equation where y equals 0. Okay. Now, you when you have a certain graph, that means the only points that you can consider are the points that are on the graph. So if I give you this point right here, which is 4 comma 3, is this a solution? No, because that point is not on the graph. Okay, it has, you can only choose the points that are right on the graph. So for instance, I'm gonna randomly pick some points. Is this okay? Yes, that's an okay point. That's negative 3 comma 2. Is this an okay point? Yes, it is, because it still is on the graph. That's negative 2.5 comma negative 1.5. Okay, so those are the only points that are okay, like this one right here. These are all solutions to the graph. Okay, now when I say, for instance, how about when x is equal to 0? Okay, what is your y when x is equal to 0? So you go to your x-axis. Okay, this is 0. Okay, on your x-axis, and then you locate the value of the y wherein the part of your graph is in. Okay, now what do I mean by that? Okay, let me see. Can I have a straight line? No, I can't really have a straight line here. Okay, so now if this is 0, so therefore you will draw an imaginary vertical line and you will hit that point. So this point right here is actually 0 comma 1, right? See that x there? That x is 0, which is what I gave, and that point is also on the graph. So therefore when x equals 0, the y must be equal to 1. Now, how do you write this in a function notation? All you gotta do is say f of x, which is 0, equals 1. Okay, so this is when you have this type of problem, that's basically giving you the x. So let's look at example number letter A. It says f of 2. So therefore this 2, this must be your x. So therefore in your graph, locate x equals 2 and imagine a vertical line that goes through that. X equals 2 is right here. Draw a vertical line towards the graph, towards the W. And this is that point, right? Don't go up here because the graph is down below your 2. So therefore what is that point? That's 2 comma negative 3. So that means f of 2 must be equal to negative 3. Okay, how about if I give you f of negative 2? Well, the same thing. Locate negative 2 on your x because that's an x, this is x, and then draw an imaginary vertical line. And where does your vertical line cross the graph? Well, it's right here. So therefore, that is also negative 3. Okay. Now, what about f of 3? Okay, f of 3. Well, again, on the x-axis, locate your 3 and then draw a vertical line. You're going down. Oops, the graph is not there, so you have to go up, 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 up. And so this is the intersection point. So therefore, what is the y there? That's also 3. So these are some examples of f of a number and what is the value of y. Now, the second question though is f of x equals negative 2. So what that means is that you're given the value of y because that's the value after the equal sign. So if you're given the value of y, instead of drawing a vertical line, you will draw a horizontal line after locating the y. Okay, so in here, your y is negative 2. So I'm going to go to my y-axis and locate negative 2. There you go. And then I'm going to draw a horizontal line. So I'm going to draw a horizontal line this way, well, I can also draw this way. And I'm gonna find where will I, it's best if you have a ruler in this one, okay? But you have grids, so that should help you. All right, so that means how many times, where did I cross the graph using my imaginary horizontal line? Well, I have 4 points, right? It's right here, it's right here, right there, and right there. Okay, so therefore, what are the x's for those values? You can just estimate, like the first one must be negative 2.5, negative 2.5, comma, negative 2. That's the first one, right? The second one here, maybe that's negative 1.5, comma, negative 2. Okay, the third one here is 1.5 comma negative 2. And the last one is this point right here, which is approximately 2.5 comma negative 2. So when you say f of x equals negative 2, you have four answers. Okay, so you can have negative 2.5 comma negative 1.5 comma 1.5 comma and 2.5. So you have four answers just for this particular problem. Okay, now let's try another example. How about f of x, f of x equals 3. Okay, so that means your y is 3. I'm going to go to my y-axis and I'm going to draw a horizontal line and find out where did I cross the graph. Well, you cross the graph in this point and that point. So therefore, what is the x there? So this is going to be negative 3, comma 3, and this one right here is 3, comma 3. Since you're given the 3 and the y, therefore your answers are the x values. For this one, your x are equal to negative 3 and x is equal to negative 3 and 3. Okay? So this is a challenge that you can answer down again in the comment below. What is f of x? Okay, f of x equals 1. Okay, f of x equals 1. What's the answer to this? All right, see you then.